All right. F of x equals x squared plus 2 times 3x cubed plus 5. We're looking for f prime of 2. Okay. What the heck does that mean? What is that? Derivative of f of x. What's it 2? What's that mean? Do what? Yeah. At x equals 2. Okay? All right. So, first dot. Using product rule, then let x equals 2. Okay, so f of prime of x, product rule. Okay? All right, let's see. Sarah Watson. Product rule. What did I do? Wayland, sorry. Coffin and Wayland. I have mixed it up. Yikes. Okay, sorry. Sarah Wayland. Sarah Wayland. Product rule.
X squared plus 2 times 3x cubed plus 5 plus x squared plus 2 times 3x cubed plus 5.
Very good. Okay. U prime B, U B prime. All right. Karina, take it from there.
Oh, I'm sorry.
It's on your notes. What do you mean you're copying what now?
I'm copying my finger just wrote
No,
that.
I'll wait. I'll wait for you.
Okay.
All right, ready?
So now we're just, okay.
Wait. Hold on.
Can I bring a style?
Dennis being a brat. Go ahead. Well, I'm sorry. I know they do. All right, go ahead.
Okay, so first one is 2x plus 0.
Okay.
Or just 2x, yeah. And then do the second
Okay.
plus 5 plus the x, yeah, same. And then 3 times 3x squared.
Which is
9x squared.
okay.
Or
Okay.
plus 0.
Plus 0. So I'm not writing the plus zeros. Okay. So hopefully you'll get to that point, all of us, that we don't have to write that 3, pull it around, times 3. We can do that all in one step. But if you're not there, don't worry, you'll get there. Okay. Now, we can plug in it 2, but let's clean it up first, just because that's what we would do if we were finishing here. All right, so cleaning, yes, Melanie.
6x to the 4th
Right, that's a 1, 1 plus 3.
plus 10x
Good,
plus 9x to the 4th.
good,
Just 18x.
nice. And we have some x to the 4th that we can combine. Okay, it doesn't matter what order it is. I know sometimes they'll put it in descending order, but it doesn't really matter. It's a list. Okay. Now we're going to plug in x equals 2. Kind of doing the notation like the calculator does with the bar and then x equals 2. So I'm going to do 15 2 to the 4th plus 10 times 2 plus 18 2 squared. Okay? What's that? Beautiful big number. 15 times 16.
Is plugging it to the second dot?
No, it's still the first dot.
Oh, okay.
15 times 4. Anybody know what 15 times 16 is? 15 times 250. No, that's 16 times 16. 240? Sounds good. 18, 40, 72, right? Lily, second. So 240 and 92 is 332. Okay? Yeah, but 20 plus 72 is 92. This is f prime of 2, just in case you forgot what we were doing. Okay? Sometimes the problems get so involved and we're like, what are we doing again? Okay, so that's the f prime of 2. We are in any questions, if there's anybody on that first dot. So now to the second dot. Good? All right. It says, oops, ends are all messed up. What the heck? All right, we're going to do green using FOIL first. Okay, so f of x. I'm just doing a different method. Alone and pull it down here. Okay. So this is my second dot. Okay? I'm going to FOIL first. So I still have f of x. All right. Rachel, would you FOIL for me, please?
Okay. 3x plus 5x squared.
Okay.
Plus 6x to the third plus 2.
Very good. Okay. And see, remember you had to spell out the foiling and all that business. You don't have to do that anymore. That's the same thing with those origins are going to be. So you're eventually not going to spell them all out. We don't have any like terms, so we're ready for f prime. Okay. All right, Kelsey Bailey. Which is?
15x.
Okay. Keep going.
10x
Nice.
plus 18x squared.
You got it. Plus 0. Okay. 5 if you're still doing 2x the first. 6, 3x squared. Good job, Kelsey. Okay. And again, I wouldn't write the 0 if I was doing this myself, just because the less you write, the more you don't have to rewrite. Okay, so that's f prime of x. Now we're ready to plug in 2. So here we go. Plug in bar x equals 2. Just separating out let x equals 2 is what that kind of notation means. This should look very familiar because this is exactly the way we put it in when we did the other method. So I know I'm going to get the same answer of 332. Hope I did it right. Okay. So that's the second bullet. All right. Anybody get lost on that problem? Okay. It looked a little shorter to do it that way, no? If you look at the amount of steps we had to take, it looked a little shorter. Okay. The third step is, third bullet is to use the calculator. Okay. So, we go to the calculator and we do math 8. Okay. Gotta pull up my function here again. All right, go to the home screen. Hello. All right. Math 8. Okay. What am I going to put in D, D, O, D, what? I'm waiting for, they're waiting for something. What am I supposed to put there? X. Did I not show you this?
No.
Oh my goodness. Okay. Wow. All right. Okay, so this is how you find a numerical derivative on the calculator. Let me write this down here. Wow, wonder what happened to that. Okay. Numerical derivative. Number. Can't do a function derivative on here on the calculator. Okay. Math 8. We're doing the Leibniz d blank x equals blank. We got to fill in all those blanks. Okay. This one is the only calculator, the only variable that the calculator recognizes. X. You try putting something else in there, it'll give you probably an error. Or it'll give you some weird thing because your other numbers are not really or they're not variables, they're stored as some numbers. Okay, so this always has to be x, all right? This is what you're taking the derivative of. This is your function. Okay, so in this case, it is right here, and you can plug it in exactly like it appeared. You don't have to do any cleanup. So, parentheses, x squared plus 2, closure parentheses, begin another, 3x to the third, get out of the exponent, plus 5, closure parentheses. Okay, the big parentheses were there from the beginning, so I didn't put those in, but everything else I put in. Okay? Now, what did we say we needed this at x equals 2? Okay? Enter. Hopefully it says 332 plus garbage. And I'm going to talk about the garbage a little bit. Yes, ma'am. Well, you just probably counted and then you didn't think about it. Okay. Now, the calculator has a brain that someone put in there, and it has algorithms to determine their derivatives. They're doing it slightly different, so sometimes it will come up with some garbage. This is all that is garbage. And plus, look, if I take it to 3 decimals, it's 332. So just be aware, sometimes it is slightly different. But anyway, regardless of which method we did, we got the same 332, right? Okay. And then this is the variable, the value of your x, wherever they have to tell you all of that. Okay? So that's how you find the numerical derivative on the calculator, which is helpful to kind of check your answer sometimes. Yes, ma'am.
So I'm assuming that on the homework for number 29, where it stated that y equaled x to the fourth and to e to the x, and then it gave you a y coordinate, were you supposed to use the y coordinate instead of x?
No.
That's what confused me. I didn't know.
I think it was, they're giving you an equation, but we'll get to it. Okay. Any other questions on this method? All right. Let's talk about the normal line, because you were like, what is a normal line? First of all, can I just say that that is the dumbest name? You all remember the regular polygons from geometry? And we were like, why do they call them regular? There's nothing regular about them, but what does regular polygon mean? No, very different than standard. It meant all the sides were equal and all the angles were equal inside. Okay? That's not a regular polygon, that's a very special polygon, right? Okay, normal line is kind of like that. Okay, the normal line is the line that is perpendicular to the tangent line. Okay? So let's say we're at 1, 1, which is, let's blow this way up here. Okay, so 1, 1 is right here. Okay? Tangent line looks like this. Ish. Look at different color. Alright, that's your tangent line. Your normal line goes to that same point, 1, 1, but it is perpendicular. So it looks like that. Okay? That normal word, normal line. These are perpendicular. Okay? All right, now, that normal line is going to just go right over the top of your head a lot of times because it's a normal word. Okay? And that normal is very specific, so keep that in mind. Yes?
So you have to, like, put in the tangent line first.
Yes. Okay, so what about the normal line slope versus the tangent line slope? They're related. How will they be related?
The normal line
That's right. They will be negative reciprocals of each other, just like we learned in Algebra 1. Okay, the perpendicular lines are negative reciprocals of each other. One's negative, the other one's positive. One's 1/2, the other one's 2. One's 3/2, the other one's negative 2/3. You got it. Okay. Why are you laughing?
It's just, I don't know.
Okay. Okay, let's go to the front. Okay, so we are finding the equation of the tangent line and the normal line to the curve. I got this so big, I wanted to keep it though. All right, so that's my task. Okay, how do we find the equation of a tangent line? First, we start with what? The derivative, because that's what? Right, the slope of the tangent line is y prime. Okay? All right, so again, keep in mind what you're doing. Don't just like, oh, I know it's going to have something to do with the derivative. Keep in mind what it is you are finding. Okay, so what is y? X radical x. Can we make that a little simpler to operate with here? X radical x. What do you think? X to the what power? 1/2. So we can put those two together, and what do we have? 3/2. Y prime is very easy if we have x to the 3/2, isn't it? All right. What is y prime, Annalisa? To the 1/2 power. Very good. Okay. Bang. All right. What's the name? Sarah? Karina. All right. Okay. Remember, we are at what value here? We're at 1. Remember, x equals 1. That's all we care about is what x is at that point. What's 1 to any power? 1 to the 4/3. 1 to any power is 1. So we have a slope of 3/2. Okay? 1 to any power is 1. All right. I'm ready for the tangent line equation and the normal line equation, since they're very much. Okay. Y minus y1 equals mx minus x1. Y minus slope x minus x1. Okay, so I know my x is 1 on both of them. Do I know my slope of my tangent line? What is that? 3/2, right? All right, what's my y value? What point am I at again? 1, 1. So my y value is 1, 2. There's the slope of my tangent line. Y minus 1 equals 3/2 x minus 1. Okay? So the only thing different that changes on the normal line is the slope. And what's the slope? Negative 2/3. We are done with the tangent line equation and the normal line equation. Okay? So now that you know a normal line, you can do that problem.
Is that all you have to do on your own? I mean, on the,
Yes.
you get the answer.
Yep, you can just stop right there. You don't have to get it in. Your y equals mx plus b4. Good question. Okay? Any other questions? Kelsey, you have a question?
No.
Okay. Tabitha, you have a question? All right. Okay. Anybody else? Ready to move on? Okay. All right. We have slope of the tangent line at 0. Equation of the tangent line at 0. Equation of the normal line at 0. Slope of the secant line from 0 to 5. Equation of the secant line. We haven't saw these two in a while. We haven't seen them. Sorry. Okay, first thing I want you to do is put that in your calculator. Let's get the graph of it. Whatever you got in here, erase, clear. All right, 4x to the third minus 2x minus 1. Graph. All right, here's your graph, just for a visual. It's always nice for me to have a visual, just because I know we're now looking at x equals 0, so there's a point right here. Tangent line probably looks like this. Tangent. Oops. Tangent line, normal line, looks like that. Okay? And hopefully that's what it looks like when we put them into our equation, our calculator. Okay, by the slope of the tangent line, part A. All right, slope tangents. How do we do that? Otherwise known as, what do you? Good. Okay, so what is the derivative? Tabitha. Sorry. Very good. Okay. We're at a certain point though, right? So we want to be at x equals 0. What is that value? -2. So my slope is -2. Okay? So this line right here that I kind of drew, we'll see how close I am when we're done, is the slope is -2. All right? What is part B? The equation. All right. I'll fill in my... Okay, I know my x is 0. I know my slope is -2. Where do I get that y value? Graph? You have to plug in the 0, so this is 0, 4 times 0 cubed, minus 2 times 0, minus 1, so it is a -1, right? So there's your equation, y plus 1 equals -2 times x minus 0, which is -2x. I do not care if you have that x minus 0.
So you plug it in to F or F?
F or F? F. Not F prime, because this is the equation of F.
Yeah.
Okay. We don't use, I know it's a little awkward because you're like, hey, you're calling it f of x, but then you call it y. We just don't use f of x in this form. It just looks weird. So that's why this is always going to be y here. It's not going to be f of x. This is weird. So if you want to clean it up somewhat, it could be this. Okay? That's your equation of your tangent line. We're not looking at 0, 0. We're looking at 0, -1. Silly Karina. All right. C, y minus blank equals blank times x minus blank. All right. From left to right. Now let me fill in my blanks on my normal line.
Y plus 1 equals 1 x minus
Okay? So all she did was switch the slope from -2 to 1/2. Okay? Good work. All right. Anybody getting left in the dust here? All right. Go back to your graph. Let's check out these graphs here. So go back to... My pen was on, that's why I'm doing. Oh, wait. Okay. Go back to y equals and put in those two equations. One is, now, you're going to want to pull that -1 around. So I'm just going to be real lazy and not even clean it up. I'm just going to put in -1 plus 2x.
need to keep that.
Yeah, keep it in there because then you'll have everything like I.
Would it be negative 1 minus 12?
Is it?
Yeah.
Well, I have a short term. Yes, it is. Memory issue here. Good work. Thank you. Okay, and then the other one, I'm going to again pull the negative 1 around, and it equals plus 0.5x, right? All right, now, graph may or may not. There's tangent 1, that looks pretty good. Now, this will look very perpendicular. Is yours? Okay, the reason it doesn't is because we don't have a square grid. So I'm going to go to my window. We have a rectangular grid, so it skews it a little bit. Go to zoom and do number 5, which is makes it a square. Zoom 5.
Yeah.
Yeah. Because it's a square now instead of a rectangle. The rectangle just skews it. I don't know what happened. I guess oh, there it is. Okay. So there's your graph. I forgot I did that third. Okay. So now it looks like it's supposed to look, and that's what we're doing. I know we didn't do D or E. I think I want to move on here.
On our test, will we be able to like graph on our calculator?
It will either be graphed or it'll be something that you can graph pretty quickly, like a quadratic or something, or it will be graphed. Yeah, I'm not going to expect you to pull that up. Good question. Okay, higher order derivatives, we're going to find all of the higher orders. Okay, as in F prime. We're going to find F double prime. We're going to find F triple prime. Okay, now once you get all those like primes, we usually start doing this. The little 4, that's your 4th derivative. And so on. You will figure out there's definitely something going on here that you really seriously are going to do all those, but you'll figure them out pretty quickly. Okay. F prime, let's see. Sarah Cohen. Very good. If you're still at -7 times 4x cubed, that's fine. 3x squared would be, and 2x. The only one you would have to slow down for is that first one, the jump there. Okay, that's F prime. Very quick. Even if you're doing it slower, it's very quick, unlike the other one. Okay. Let's see, Chelsea, give me F double prime. And 28 times 3, anybody know what that is? 84. Okay, sounds good. Okay, go ahead.
Okay, so -84x squared.
Good.
Minus 6x plus 2.
Nice. Okay. All right. F triple prime. Karina. 84 times 2 is 168.
Negative 168 minus.
Very good. All right. Lauren, how about the 4th prime? 4th derivative.
Would it be negative 168?
Yes, ma'am. Good job. And what about the 5th? Olivia.
0.
And the 6th. And the 7th. So all the rest of them are going to be 0 because they're all going to be constants. Right above 0 is 0. Their derivative of the constant is 0. Okay, so that's why I didn't list anymore. Honestly, remember this was called, if this was the distance, this would be the velocity. What was the second? Oh, no. Back up. Let's say this was the distance. Hello. If this was the distance, what would this be called? And this would be called and they called this the jerk. Again, your applications are going to involve these two guys. Okay? They're not getting involved too much after that. I haven't seen the jerk come up, except if you were picking it out of the ground. Like we did before, so. Yes, ma'am.
So what would like a question be on the test? Like how, would it be like an application question?
It could be just find the second derivative. It could be find the concavity, which involves the second derivative. It could be find the velocity, when it's going forward or backwards.
So like if it gave you the distance as a final acceleration.
Find the second derivative, that's right. Okay. All right. Should we do D&E? What else? We don't really have time. That's just a specialized. Let's do D&E, just because we haven't seen it for a while. And I'm going to start a new page because, all right, so we're going to do D&E over here, secant line. All right, so my equation looks like, you recall before I put all that goofy stuff on there, it looks something like this. Okay, that was my f of x. All right, what we want to know is the equation, the slope of the secant line from 0, this is an interval, to 5. 5 is probably, for 5 way up here, but let's just pretend it's right here. So this is 0 something, I think it was 0 negative 1, wasn't it? And what's the 5 something? It's way up on graph, but I go to my table, it's 5 negative 11? Oh no, sorry. 5 489. Ooh. Okay, so it's way off my graph. But if you wanted to find this value, remember you just plug in 5. Or 5 to the third minus 2 times 5 minus 1. It's 489. Okay? So we are looking for that slope. Okay? How do we find the slope given in 2 points? Slope formula. Okay, a lot of you have that in your calculator. Y minus other y over x minus other x. Okay, so what's that? 490 over 5. Very steep line. We knew that because it was way off the graph. So what's x? 80, 90, 98. Okay, that's the slope of that line. 98 is the slope. Yes. Slope equals 98. Okay, now we're ready for the equation. So for E, y minus blank equals slope x minus blank. Okay, 98 goes there. We can either put 0, negative 1 in here, or the same line would be 489 and x minus 5. This is the same line. If you don't believe it, put it in your calculator and see. It's the same line. Okay, and neither one's better than the other. Thank you for not jumping into your seat. Sorry.